Okay, so here's part 2 of our exponential zombies activity. So now we're going to talk about fighting the zombies. So the Southwest High School Health Science Academy has banded together to fight Mrs. Kruger and her zombies. Each day they defeat half the zombies. Okay. Make a table and graph that will help us figure out how many days until all of the zombies are defeated. Okay, so remember that we had 900 people in the cafeteria during B lunch. And so day 0 at the beginning, we have 900 people infected, 900 zombies. The Health Science Academy has figured out how to defeat half of the zombies every day. Okay, so now, as we move through our table, instead of multiplying by 2, we're going to be dividing by 2, or multiplying by 1/2. So if we have 900 people the first day, we're going to cut that in half, and the next day we will have 450 people infected. Okay, so we've killed 450 zombies, we have 450 left. Day 2 is half of that, so we'll have 225. Day 3, half of that, we have approximately, I'm going to round up because we would have a decimal, it's going to be 113. Okay. Half of that is going to be 57. Again, half would be decimals, but we really can't kill half a zombie, so that's why I'm using the whole numbers rounding up. Then that's going to be 28, 14. Oh, just kidding. 25. No, that's right. 29, 15, 8, 4, 2. Okay. So it says, describe what is happening to the number of zombies each day. So the number, oh, can't see that, is being cut in half. Okay, so it's decreasing. It's being cut in half. The next question says, is this data linear, quadratic, or exponential? Now, we already know what's coming because we know what kind of functions we're talking about. But let's go ahead and look at what that data would look like on the graph. So again, here's my coordinate plane. My x-axis is going to represent the number of days. My y-axis is going to represent the number of zombies. Okay. So I'm still going to go by ones here, 0, 1, 2, and so on. Okay. To show all of my data, I need to get up to 900. 2, 3, 4, 5, 6, 7, 8, 9, 10, 21. I'm going to go by 50s. Okay. 50, 100, 200, 300, and so on, to see how if I can get how much of this data I can get onto my table. So that puts 900 right here. Okay. Now I'm going to plot my points. Day 0, I had 900 zombies, so I am right here at the start. Day 1, we had 450. Day 2 was 225. And I'm going to continue plotting the rest of this data. And it gets to the point where we really can't squeeze it any tighter, okay? It's because we're running along closer and closer along that x-axis. Okay. So again, we can see that this data is exponential. Okay, our points fit that exponential curve. So this is definitely exponential data. Okay. Then it says write a function that could represent this data. Okay, so we're starting off with our same parent function. F of x equals a times b to the x, where a is our initial value and b is our rate of increase or decrease. Okay, basically it's what are we multiplying by every time. So our function is going to be y equals, our initial value was 900, we started out with 900 zombies, times, we were dividing by 2, so that means we were cutting them in half, so that's going to be 900 times 1/2 to the x power. That's our exponential function. Okay. Now, this one's kind of a tricky question at the end. Based on this function, would the number of zombies ever really reach 0? Okay. Now, technically, if there were actual zombies walking around, yeah, if you're killing zombies, you're going to kill them all. But what's happening is we're multiplying everything by 1/2, times 1/2, times 1/2. And so, technically, with the function, it would never really reach 0, because if we only take half of something, it always leaves a little bit there. So, no, it would never really reach 0. It would just get closer and closer to it forever and ever. Amen. Okay, because we would always be leaving a little bit there. Okay, so again, let me know if you have any questions. This is just a way to demonstrate what an exponential function looks like. There's going to be one more video where we go through some notes where we're actually looking at like word problems and writing growth functions and decay functions. It'll look a little more mathematical, but I just like to use this zombie thing because it's a little more interesting to see what the numbers would do in a somewhat real life example. Okay, I'd love to hear from you this week. Make sure that you are touching base with me once this week. It's the easiest 100 you'll ever get. Send me an email, send me a message, check into one of my Zooms, and hopefully I will talk to you soon.